Hello everyone, I am Abhishek. My other two teammates are Pritam Shekhar and Pranita Chandra. Today, we are diving into the crucial topic of building the front end, especially focusing on how we manage a state to achieve massive scalability. The front end layer in large systems is more than just HTML and JavaScript. It is the entire infrastructure that handles the client's connection. The connection itself, the network components like load balancing, firewalls, server instances that directly respond to traffic. The layer is our first line of defense. It handles the highest traffic and concurrency, meaning any flow here directly impacts the user experience. Proper design is non-negotiable for high scalability and performance. Here, our front end must adhere to four key characteristics. Firstly, we will discuss statelessness. This is our most critical concept. The servers must not store no user data between requests. Every request must be treated as a brand new. Secondly, caching. We use caching extensively to reduce repeated work, whether at the CDN, the reverse proxy, or in the browser. Then, horizontal scalability. We must be able to add more servers to handle increase not without redirecting the code. Now, finally, fault tolerance. If any single server fails, the system continues to operate seamlessly, and any other server can pick up the request. Now, we when we developing the client slide, we generally use three models. Firstly, traditional multi-page application. Every user action reloads the whole page. It is simple but slow. Then single page application. This is the modern. Logic runs in the browser using async constants for partial and fast updates. Then hybrid application. A mix of these two, often used in large scale systems to balance performance with search engine optimization. Regardless of these models, our focus for scaling is always the same, removing local states, maximizing caching, and parallel workloads. So, why is state management so vital? Because if a server is stateless, it can be easily replicated. This is the secret to horizontal scalability. All the unique user data, such as the session, the shopping cart, must be stored in the shared storage. Now, let's contrast between these two. Stateful server. It stores session data locally. If user A is connected to server 1, then it must return to server 1. If server 1 fails, user A is lost. It is hard to scale and recover. Now, stateful server. As it stores no data locally. It fetches the required user state from a shared storage system on every request. Any server can handle any user. Now, this diagram shows the stateful problem. Users are tied to a specific unit holding their session data. Now, look at the stateless model. The servers are identical and interchangeable. They check the shared storage, user as session data, and system is instantly scalable and fault tolerant. Designing a system to be stateless is like walking into a pub and paying cash for each drink. Any bartender can serve you quickly. Whereas a stateful is running in a tap, you are stuck with one bartender. Thus, statelessness increases our flexibility. Finally, we can say that statelessness enables easy scaling and redundancy. Shared storage ensures data consistency. Proper caching and distribution strategies reduce load. The front-end servers should remain identical and interchangeable. This is our presentation. Thank you, everyone.
Assalamu alaikum everyone. Today we are going to discuss about building the front end layer. This is the third chapter of web engineering 6th semester. Well, our group number is 10. We can see our group info here. My name is Tanjim Arnab. We also have Sabrina Sultana, Hafiz, Hasnat, Sifat, Jami, and Muznabin Ahmed. Our IDs are written under our names. Well, this chapter was divided in several parts and was given to 6 groups. The the topics for our groups are managing HTTP session, managing file, and managing other type of states. Now let's jump to our topic. First topic is managing HTTP session. Well, what is HTTP session? An HTTP session is a temporary interaction between a client browser and a server. that allows data to be maintained across HTTP requests. Well, HTTP session is a stateless protocol. What we mean by stateless? Stateless means the requests are independent. When we send a request to the server, it's independent and go by itself. And when the server also replies to the user, it's also independent. Well, what a HTTP session maintain? We can see a HTTP session maintain user authentication and login status, storing temporary data like cookies. We can say a cookie is a HTTP session. We all know that cookie is a small piece of data stored on the client's browser to identify user. We also have tracking user activities and preventing unauthorized access. Well, our next topic is managing file. Well, managing file is quite simple. Managing file refers to the process of creating, reading, writing, updating, and deleting files in a computer system. Well, we have two types of file. One of them are text files and one of them are binary files. The text file that text file means a human readable file. uh, the file we are reading is a text file. We have text file like txt file, json file, csv file. Well, the binary on the other hand, the binary file means the file made of 0 and 1. We do some operation on the files like creating file, reading file, deleting file, and writing file. Well, creating file is used for creating a file or making a file. Reading file, addressing data from an existing file. Write, adding or modifying data in a file. And delete removes a file permanently. For in here we can see an example of creating a file. In here where we have written a code to create a file name arnab.txt. Well, let's jump to the last topic. Uh, Now let's discuss about managing other type of states. Well, apart from application and UI state, modern front-end system often used to manage additional types of state that are external, temporary, or drive related. Those include data stored in browser, URL parameters, and data and synchronous data from APIs. Well, managing other type of state ensures that application maintain consistency between client side, server side, and environmental data sources, allowing for smoother user experience and predictable behavior. Well, why we need it? We need it because synchronization, maintaining URL, presenting temporary user settings. In here we have few types of other states like server states, which is responsible for what? Represented data fetched from an API. Well, we also have URL state, refers to data stored in the URL. Also, we have browser state and drive states. Well, the advantage of using it are they help us to improve the performance, provide flexibility, and also help us to access data faster. For example, cache is also one of the managing others type of state. We know cache helps us to access data quickly. It stored data information or stored data that are frequently used by the user. Well, that was all about managing others type of state. This was the last topic for our group. Thank you everyone for listening to our presentation.
Hello everyone, we are group 2 and today we will be discussing the DNS part of our topic, building the front end layer. So first of all, what is DNS? DNS stands for Domain Name System. It's basically the internet's phone book. It translates human-friendly names like Amazon.com into machine-friendly IP addresses like 192.168.1.1. In a scalable front-end architecture, DNS serves as the entry point. Whenever a user opens a website, the browser first asks DNS, "What's the IP address of this domain?" DNS then points the browser to the correct server. If we look at this diagram, we can see the entire flow. It starts with the client, which is the user's browser. Then the request goes through DNS, then the CDN, then the load balancer to the web server, and finally to the backend where data and files are stored. So, in simple terms, DNS helps connect users to the right infrastructure quickly and accurately, and that's what makes the modern web work smoothly.
Now let's move on to how smart DNS works. Using Amazon Route 53 as an example. Traditional DNS just translates names to IPs, but Route 53 takes it a step further. It uses something called latency based routing, meaning it measures how fast the connection is from the user location to different data centers and then sends them to the fastest one. For example, let's say a user from Cuba wants to visit your website. Route 53 checks the latency to different data centers, maybe one in Dublin and another in Los Angeles. If Los Angeles responds faster, the user is automatically routed there. This means every visitor gets connected to the closest or best performing server in real time. The result is a much faster and more reliable web experience. So, smart DNS like Route 53 doesn't just resolve domain name, it actively optimizes the user route for performance. That's a big reason why large websites like Amazon and Netflix can serve millions.
Now let's move on to another important concept, DNS based load balancing and why it's not always the best option. Sometimes websites try to distribute user traffic using something called DNS round robin. Here how it works. When multiple servers host the same website, the DNS server gives out different IP addresses for that website in rotation. So one user might be directed to server A, the next to server B, and so on. At first, this seems like a simple way to balance load, but in reality, it has a big limitation, DNS caching. When a user's browser or internet provider stores a DNS response in cache, it keeps using that old IP addresses for a while. So even if one of the servers goes down, users might still get directed to it because their cached DNS record has not expired yet. This delay makes DNS based load balancing slow to respond and sometimes unreliable in real world scenarios. That's why modern architectures use dedicated load balancers after DNS resolution. Unlike DNS, these load balancers can continuously check the health of servers and instantly reroute traffic if one fails. This ensures requests are always handled by healthy server, keeping the system fast, scalable and fault tolerant. So to summarize my part, DNS helped decide which region or data center a user should connect to, and the load balancer decides which specific server will process each request. Together, they form the backbone of efficient global web delivery. So, DNS translates names to IP addresses. A smart DNS service like Route 53 improve performance with latency based routing and Traditional DNS round robin has limits. That's why load balancers handle real-time traffic control. Together, this system make modern web application fast, reliable, and resilient. Thank you.
Hello everyone, I am Mamun. Here is my presentation, building the front-end layer. But topic is caching and auto-scaling, and our group is starting. Okay, let's start it. Caching. Caching is the process of starting temporary copies of data in a faster, more accessible location to speed up future requests. For web engineering, this involves storing copies of web files like images, scripts, and HTML on various levels, including a user's browser, a CDN, or a server to reduce latency and server load. Here are different types of bullet. We see that caching stores data temporarily to serve users faster. It reduces load on web servers. So it reduces load and saves many times and memory space. Common types: browser cached, CDN, reverse proxy, object cache, etc. Then here is the true picture of the cache: web cache, server to web cache, and there are three client 1, client 2, client 3. They request to the server, then server collects the information from the web cache. And first picture, browser server, there are request and a response. Why caching is important? Improves website speed and performance, reduces server workload, helps website handle more visitors, saves bandwidth and resources, enhances user experience. For these reasons, caching is important. Types of caching. There are 4 types of caching: browser caching, server-side caching, object caching, content caching, or CDN. There are in a picture we have adjusted. Full process of caching: web or mobile, then request to a load balancer, web server, then cache. Thus, we have analyzed the cache process in a picture. Content delivery network or CDN. What is it? Network of servers worldwide stores copies of website content, etc. The remaining part we will discuss Ikwan Hussain Ashik.
Assalamu alaikum everyone. Content Delivery Network (CDN), network of servers worldwide, stores copies of website content closer to users, reduces load on main server, improves website speed globally. Now next slide. Object caching stores frequently used data in memory for fast access, reduces database queries, speed up dynamic websites. Now challenges in caching. Cached data may become outdated, hard to manage for dynamic websites. Too much caching consumes money. Incorrect caching can show wrong or old data. Needs balance between speed and accuracy. Now auto-scaling. Auto-scaling adds or removes servers automatically based on traffic, used by cloud services like Amazon EC2 and Cloudist. Why auto-scaling is needed? Prevents website crashes during traffic spikes, ensures a smooth user experience, saves cost by saving servers only when needed, keeps website reliable and efficient. Now remaining part will continue Rakibul Hassan.
Assalamu alaikum. I am Rakibul Hassan, another member of Group 13. How auto scaling works: monitors server load and website traffic continuously, adds servers when load increase, removes servers when load decrease, uses rules like CPU users, memory users, or number of requests. Here are the picture how auto scaling works. Auto scaling function. The benefits of caching and auto scaling: faster website performance, so it efficient use of server resources, handles more visitors, improves overall reliability and user experience. Here is the conclusion. Front-end scalability depends on stateless design, caching and auto scaling. Together they make websites fast, reliable and cost efficient. Thank you. Assalamu alaikum.
Assalamualaikum, I'm Sanjit Akhtaripar. Today I will explain how we can build and deploy the front end layer of a web application using Amazon Web Services. This setup ensures high performance and auto scaling. Let's start with Route 53 DNS. It's basically a domain name service system that routes users to the nearest or fastest servers, improving speed also. The next one is the Elastic Load Balancer, evenly distributes incoming traffic among servers to prevent overload. It also handles secure HTTPS connections and works with auto scaling to adjust automatically as demand changes. Next one is EC2 instance. Our frontend runs on EC2 instance in an auto-scaling group. These servers are stateless, so they can be added or removed easily, keeping the systems efficient and cost-effective. The next one is S3 and CloudFront. For static files like images, CSS, and JavaScript, we use Amazon S3 and CloudFront. S3 stores the files securely, while CloudFront delivers them from the nearest location for faster load times.
Now, if we look at the diagram on the right, a user first makes a DNS lookup through Route 53. Their request then goes to CloudFront, which serves cached or static files directly from S3. For dynamic content, CloudFront routes the request to the Elastic Load Balancer, which distributes it across multiple EC2 web servers. These servers communicate with the backend layer or private S3 buckets when needed. Finally, CloudWatch monitors system performance, and autoscaling ensures the infrastructure adjusts automatically to keep everything healthy and responsive. To sum up, this front-end architecture powered by Route 53, ELB, EC2, S3, and CloudFront delivers a fast, secure, and scalable experience for users around the world. It ensures continuous performance with minimal downtime, while AWS automation handles scaling and monitoring seamlessly. Thank you.
Our second deployment scenario is private data center hosting, where we use our own hardware servers instead of cloud service. This setup gives more control, better performance, and very low latency between servers. However, it requires manual management. We don't get auto scaling like in the cloud, so we must plan capacity carefully before traffic increases. Here, a hardware load balancer is used to handle request and distribute traffics. For storing files, we can use different systems such as FTP server, storage area network, or even NoSQL data stores depending on our needs. Private data centers are also useful for companies that must follow strict security or legal rules, like keeping all data within a certain location. Overall, while cloud hosting is cheaper and faster to start with, private data centers become cost effective and reliable as infrastructure grows, offering maximum control, performance, and security.
Private data center hosting is a deployment model where web applications run on dedicated physical servers instead of cloud infrastructure. In this setup, only a few services like DNS and CDN can be easily outsourced. Using bare metal servers provides major benefits such as predictable latency, high throughput, and sub-millisecond communication between servers. However, it also demands manual management. There's no auto scaling, so capacity must be planned carefully in advance. A hardware load balancer like HAProxy or Nginx handles incoming requests and can include caching or reverse proxy layers to improve performance. For file storage, options range from FTP servers to storage area networks or NoSQL data stores depending on data size. Files must be served through a CDN by adding a web server layer in front of storage. Although cloud hosting is cheaper and faster to start with, private data centers become cost effective and powerful as systems grow large. They offer better performance, lower hardware costs at scale, and are essential for organizations with strict security or legal requirements, such as those requiring data to remain in specific locations.